Hello everyone. Today's lesson will be about professional code, about code which everyone should write. This is language independent. Those rules apply to every language. The goal of these lesson series, and there will be 8 of them, is to familiarize you with ways of how to make code more readable, understandable, and maintainable. It's those kind of rules which don't really need any specific technological experience, but it's something that you need to grow with. And the sooner you are familiarized with those rules, the easier it will be to apply them in the future. I myself am still learning and trying to fully apply them in my daily programming routine, but knowing them helps, understanding them helps, and that's the guidelines that I think every programmer should follow when writing code. So, clean code, easy to read and understand. Let's start from the first lesson. What is clean code, you might ask? And in my opinion, clean code is code which is easy to read. And by easy to read, I mean words written, lines of code are short, lines of code are not ambiguous, words you read are easy to pronounce. Basically, code written in English, code that you can understand without too much of experience, of technical experience in a specific language, is what I consider clean code. Easy to read code, sorry. Code which is easy to understand, which means similar to easy to read, but easy to understand means that the intention of what you wanted to express in code is clear. You don't want your code to be easy to read, but at the same time you understand what you read, but you didn't understand why someone wrote it. The intention needs to be clear, so easy to understand why and what was written. And of course, easy to maintain. If readability and understandability is something that you can grow to, like in a project, you get familiarized to a project and then readability and understandability comes in time, maintainability does not. Design rules applied early on will be the determinant factor, which determines whether or not your project will be maintainable or not. And for those 3 reasons, clean code is extremely important in every kind of solution that you write. So imagine this sadly quite common situation. Someone comes up to you and says, "Hey, could you look at my code?" And you reply with, "Sure, what's up?" And then to your horror, the reply is, "Line 9802 in filecore.cs returns wrong value." And you're creeped out and reply with, "Oh, what's in the line?" And then you see this. And you're left speechless. This is horrible code example, but unfortunately this code exists. And I'm pretty sure that some of you have experienced something like that. I have personally, but I don't want to be reminded of it. I don't want to look at it. and I don't understand what's written there. Semantically speaking, I understand everything, but readability wise, it's just noise, and it's really hard. By the time you read a part of it, you forgot what you read initially, and it's a mess. Code like that should not exist, and if you see something like that, you should refactor. So why do we need clean code? Basically, if you think about it, 10% of the time we spend is spent writing code. Most of the time we read code, not write it. And thus, the dirtier the code is, the more time it will take for us to read it. Why would we want to sacrifice the 90% of the time and make it even more? Or we don't want to take away time from writing code. We want to increase the time. We don't want to read something. We don't want to reread something. We do that plenty enough. So remember what we wrote. With clean code, it will be much easier to do that. Find what and where went wrong. The intention, a clear intention, will definitely improve the probability of us finding what went wrong faster. Because we will not have to be forced to look into details of our functions, of our classes, if everything has good abstraction, encapsulation, and if someone was programming with empathy to another person, we will find those things easier. And of course, if you get into a project and everything is written without following any conventions and everything is all around the map, it will be really hard to get into such a project and understand the purpose of code. So, in long term, clean code is amazing. It improves productivity, it improves even the way you feel, because reading clean code, just like being in a clean room, gives a whole different feeling. And this is a beautiful example of what a measure of good code is. The actual only good measure of good code. So it's WTFs a minute. Basically, if you go to a code review, and if there are a few things that went wrong, if there are a few things that the reviewer did not understand, that code is fine. It's hardly ever possible to be perfect with code. Everyone makes mistakes, and it's fine, as long as you learn from them. But if your whole code is a big mistake, if it's full of those, that's a measure of bad code. Many WTFs a minute in a code review is a mad measure, is a sign of a bad code. So let's start with naming. And here is a quote saying that naming things is the hardest of things that programmers have to do. Naming is the easiest and hardest way to express ourselves and to show intention of what our code should do without looking into details. So imagine if we used names that were arbitrary, like in the picture, with emojis encoding our typical types or symbols. That would be horrible. So sometimes our code looks like that, even though literally doesn't mean that, but especially beginner programmers write code which looks messy. Maybe they call a variable letter A and then write a comment what it is. That's horrible, and it should be avoided, and it should be introduced as soon as possible so that such dirty code is avoided. So if you try to read your code and look from a point of view of someone else, and if you think that your code is or might not be understandable, you should rewrite it, rename it at least. So a very typical example is when you have a function called process something, or a function validate, which should validate, but what does it validate? It's all about design rules, it's all about naming, it's all about clean code, and if you fail to understand that, it will be really hard to read your code and understand the intention. So, for example, these are the basic naming rules, and on the left you see good examples, on the right you see bad examples. Let's say you're supposed to iterate through lessons. And let's say you're supposed to you don't have any object about lesson, but all you have is an index. But you know that index is for a lesson. So you shouldn't call it index, you should call it lesson. Because you don't have lesson object, you just have lesson index. So index is too abstract, and since you know that the index is for a lesson, you can call it lesson. Now, if you have both an index and lesson as an object, lesson should be a default name for a lesson, and index should be a suffix to a lesson. If there are multiple objects that you're iterating through, index could be without prefix lesson, just index. So on the left you see naming with the tips I just said, and on the right you see naming instead of writing what it is logically. On the left you write what it is logically, and on the right you write what it is semantically, a type that defines what the object is or what the type is. You don't want that, because it doesn't give any extra info other than the info that we already know. Lesson int is an integer because that's the type that defines it. We don't get any extra info. Or lesson object, lesson is an object. You don't need to write that again. So don't do it like that, like on the right side. So if we have, let's say, a single object, but we create a specific, like the object we create, it has a specific meaning, we don't need to redefine the meaning in object's name, because we shouldn't work with details and specifics. We should be as abstract as possible. We should have just enough info as long as it's meaningful. So if our shop gets to buy and sell items, shop is all we need. We don't need tailor shop. Shop is enough. For beginner programmers, I also noticed that sometimes code is written in their native language, and sometimes comments, actually especially comments, are written in their native language, but you should stay consistent and write code in English only. Right, so code should be easy to pronounce, and you see on the left and right two basically identical things. Sly is mischievous, but how long does it take for you to read sly? And how long does it take for you to read mischievous? First of all, it's hard to read. Second of all, it takes at least a second more to read it. Half a second more to read it. But still, time is a resource and we don't want to waste it. And if we can't save it, we should. It will accumulate to something. So save it where you can. Short names, easy to pronounce names, whenever possible. Imagine that your team has a tendency to write a suffix to all models, to all business entities with entity. So even though it's not the best practice, you should stick to it and you should say target entity instead of just target, because that's how your team did it. Stay consistent in a level of team even though it's against conventions. What's the worst is staying inconsistent across level of solution. The smaller the level of scope of inconsistency, the less bad it is. But when you're inconsistent across the level of project, it's horrible. Conventional unless arbitrary. Right. So stick to conventions. Anyway, stick to conventions unless your team says so, or unless your project is consistently written bad. You either refactor everything, or you keep to the conventions of to consistency of a project, even though it's bad. And of course, do not use keywords. Namespace. Project name as a class name, type names as class names or class suffix, and so on and so forth. It's just not the right name. Don't use keywords. Stick to the abstractions and create your names, or use names from conventions. And here you can see the last example, home controller and controller for home. You know that, let's say in MVC app, you have controllers and controllers have suffix controller. Don't reinvent that and keep to the convention. Home controller is the class responsible for the business logic of your view. So don't reinvent the wheel and keep the name how it was designed. Unless, of course, the team has different conventions. Sometimes people don't know when to write var. And the answer is very simple. Almost always write var, because it provides no extra information. The type itself. It's faster to write, and sometimes you don't have to care about the type. On the other hand, if it's really hard to determine what the type is just from the name of a function, for example, in this case, we have get amount. Amount could be an integer, it could be a float, a double, decimal maybe. We don't know. Sometimes we don't care either, but when we do and when it's not clear and when it's important, for example, when you divide amount from an integer, a type will decide how the division will work, what will the result be. So when the type matters like that, you should specify it explicitly. Don't be afraid mixing var and explicit type, because the intention is what matters the most. If it helps to read it better, use the type explicitly. So in this case, we wrote int amount because we cannot tell what get amount returns without looking inside. So we spend time looking into details when we can just save time writing a type explicitly. When type needs to be emphasized, we might want to also write it explicitly. In this case, it's not so useful. Main controller can be with var, but writing main controller emphasizes it. So in this case, it's questionable, but maybe it's a team convention. Maybe someone wanted to emphasize that it's main controller, even though you can see that from the new main controller. Anyways, again, if your team doesn't use var, you shouldn't either. Stay consistent. When it comes to naming, you should spend plenty of time. So stop for a few moments and consider a good name. A good tip for naming is to first look up framework, your chosen framework. Look how they do it. Look how they name the same operation that you would implement. And based on that, do the same. A similar name will work really well. And like that, you will stay consistent to the framework. But don't spend too much time on naming. Sometimes it just comes naturally. Sometimes you will write something ahead and you'll go back to the place because you had an idea how to name it better. So this picture is quite a funny illustration where initially you're taking forever to come up with a domain name, which is very important. And then you're taking forever to come up with a project name, which is also very important. And then you're taking forever to come up with a function name, which is also very important, but not so much, of course. And then you're taking forever to come up with a single variable name, which is also important, but again, not so much. Like the importance of a name goes down in importance from top to bottom. And then you just make a meme because you can't figure it out. So yeah. And if you're curious about language conventions, specifically about C#, you should visit either of these two sources. The first source is made by community on GitHub. And the second one is official Microsoft source. And those show standards and conventions, how you should name your things. And in this chart you can see conventions, the most basic and typical conventions for C#. Class names, constructors, method names, constants, properties, delegates, and enums are all Pascal case, meaning that they are capitalized and every word is capitalized. First letter, I mean. Some people think that constants should be full capitalized, and that's not true. In C#, we don't follow that notation, and that notation is called Hungarian notation. We don't follow that. In C# we write Pascal case. So other than that, everything in C# is camel case, and fields are with underscore prefix. Now let's move on to comments. A comment quickly becomes an accuracy, a gossip, which in time transforms into a lie. You do not need comments because code speaks for itself, and good name is better than a good comment. Comment disrupts readability. Basically, comments get old too fast. Code changes, comments often does not. And for that reason, writing code more clear instead of a comment which makes it clear is much better. Look at this example where you write connection.initialize and you write a comment, initializes connection. Well, no shit. Of course it does that. It's obvious. Don't write comments like that. It's just noise and disrupts readability. Actually, when I write code, comments take at most 5% time of code, at most. I still write comments, and soon you'll see why I need them. When you're learning new things, a comment is helpful. Comment is easier to write than to separate a block of code into a function. Especially when you're learning, you want to have code close to each other. You don't really care to decouple it, to split it into parts. You want to have it for learning purposes. So a comment in that case helps. In all other cases, a function should be split instead of a comment block, written what a block of code does. And in what cases do you need a comment then, professionally? Well, sometimes you cannot express yourself good enough with code. Sometimes your naming will not express the intention that you wanted, and for that reason a comment will help. Let's say if you need to write a really long name, instead you could write a comment. Sometimes that's a better, one of the lesser evils here. Sometimes there is code which might be dangerous, which might be kind of obvious and not really, which might be questionable. And you might think that you will remove it and refactor it. But then if you see a comment, you might be familiarized with the consequences of what might happen if you remove the comment. The code block that was with a comment. So explaining consequences is also a reasonable use case for a comment. And here you can see memes of comments. For example, when you delete a block of code that you thought was useless. A comment would help, right? Without a comment, you refactor, hey, it works, but then it does not. Maybe naming would help, better naming, but maybe not. And in those cases, a comment could. It helps us to familiarize and memorize what we wrote. Of course, naming stuff is the way to do it, but when we fail to do so, even after spending a good amount of time of renaming stuff, sometimes we need a comment. So, before writing a comment, think twice, refactor, and even then, if you still cannot write a good name for a function, variable names, class names, write a comment. So here is an example of how you should refactor a function, a class with comments into a class without any comments, and a class without any comments in this case is much more readable than a class with comments. So when you have magic numbers, you should refactor them into named constants. If you consider writing a comment, rename and restructure. That's what you should do. Go to 2 tips. So in this case, we have a salary controller controller is a bad name. Calculator is a much better name, especially since the comment says that. We have a constructor which does nothing, so we delete it. And then we see a comment, calculate salary based on taxes and bonus. We get input salary. Okay, that is clear already. And based on taxes and a bonus. And down below we see what that actually meant. So 085 is tax 1, 099 is tax 2, and bonus is 1.07. We wrote a comment for it. What if it changes? What if the order of those multiplication elements changes? The comment will have to change, will it? Most likely not. So please do refactor. And on the left side, you can see how a refactored version looks like. Calculate after taxes, salary, and all the commented variables are now named constants, and we return a nice result. Salary after taxes. And now let's talk about code structure. So here is a nice quote. Writing code is much like writing a book. You start with words, make sentences. Sentences go into paragraphs, which in time morph into chapters. So keep related code close. Declare variables close to their usage. Related code should be vertically dense. In the top, you see everything is squished together. Spaces are saved. Height, width, price per square, count, squares times height, width, total. Oh my god, everything is mixed. I don't know what happens here. It's a mess. At the bottom, you see height and width, and you see squares. You get squares multiplying height from width. So probably how much space in squares does it take? You get multiplying those two. And the intention is much more clear, and the related stuff is all together, and it's much more readable now. And price per square is 1. There are 2 squares, so total for the total price of squares is squares times count times price per square. And the intention is much more clear now. So keep lines short. Don't break indentation, and use whitespace to associate related things and deassociate weakly related things. I think the first 2 are obvious, but the third one might not be so much. But look at this. There is a formula for counting determinant and square equations. Square of b minus 4 times ac is the determinant. And in the first equation, actually that's the way Visual Studio would format it for you if you pressed Ctrl K and D, but that is less clear because you can clearly split the equation to 2 parts, for square of b and for ac. And if you remove the spaces between those, you get a more readable, more familiar equation. So even a space, not even an empty line, but a space can make the intention more clear. And there is also a rule to keep lines short, and also there is law of Demeter, where you use the internals of a class and then you call internals of a class to call something else. And law of Demeter says that you should tell and not ask. And by telling, not asking, reduces length of a line and makes it more readable as well. It also encapsulates better. But anyways, the point here is that we have trains. We get first train, which has a status 0, 0, 1, and then that train goes somewhere. What is a status 0, 0, 1? Okay, it's a train OK status, because we see that in the example of refactored function line. And so a train with status code 001 is a train which is OK. So an OK train, we get an OK train first, and then OK train goes somewhere. I think reading code like this is more clear, because a single line does a single thing. In the first example, we do two things. We get a train, and then we tell it to go. In the second example, we get a train, then that train goes somewhere. Two lines, two actions. You should not do multiple things in a single line. It's not a clean approach. Instead of this, we could also have written .go, but in a separate line. That would work as well. And that's it. So those are the very basic rules which go into level of raw code. Quite easy. And now, if there is anyone here who would like to do refactoring workshop, I can cover it with you, but I will need to see that in the chat. So write if you want to do refactoring workshop with me. If not, the lesson will end here. So write in chat and we'll see. I'll wait a minute, and if nobody wants, we'll end the lesson here. All right. So thank you for your attention, and see you next time. Next time there will be a lesson about functions. How do you refactor functions? It will be probably a more interesting lesson. So till then, bye bye.